So moving along in Unit 11, we're going to now talk about assessing intelligence and what some intelligence tests look like and how we kind of figure out what is that number and how is that developed throughout history. And we need to keep in mind some of the theories that we talked about in our last set of notes. So psychologists define intelligence testing as a method for assessing an individual's mental aptitudes, that makes sense, and then comparing them with others using numerical scores. You need to underline that comparing them with others component. Because of course they give it a number, right? They assess it and they give it a number, but that comparing it to others part is a little fishy at first, but we'll kind of explain what that means. So let's talk about the history and how the intelligence test has become what it is. Alfred Binet and his colleague Theodore Simon developed the first standardized intelligence test, and we'll talk about what that standardization part means. Don't assume you know what standardization or standardized test means. It's a little different than the way that we might just think of it in schools. It's a little more, I should say. So they were commissioned by the French government, they being Binet and Simon, to design a test to identify French children who would have problems in regular classes, okay, so in the everyday classes of school. They set out to find what's called a child's mental age. You should make sure that you have this definition in your paper. Mental age is the average age of individuals who achieve a particular level of performance. This is what then the mental age of 6 should be able to do. Okay, so if a child is 4, yet they're meaning 4 years old, yet they're at the mental age of 6, that means they are intelligent or academically advanced. Binet did not create the test to label children. That was not his goal. He actually warned that if the information that he came up with were misused, it would do just this. Instead, he wanted only to find a way to help improve the educational experience of French children, rather than just label them and we be done with that child. Louis Terman in the United States then adapted and revised Binet's test for American school children and named the test the Stanford-Binet IQ test because he worked at Stanford. A form of the Stanford-Binet test is still in use today. Okay, so this is the very widely known IQ test, and a form of it is still being used. Today, the Stanford-Binet is given orally and varies in nature according to the person taking the test. There's the children's version. They're given figures to copy or everyday problems to solve. And then adults are asked to solve analogies, explain proverbs, and describe similarities that underlie sets of words. The examiner begins by finding a mental age for that person, meaning at which person can answer all the questions. They move on to more difficult problems. When the mental age is reached at which no items can be answered, the test is over. So once the person can't answer any more questions, you realize, okay, you're not at that mental age, so we have then found your mental age. All right, William Stern is the guy who came up with the intelligence quotient. The formula of the intelligence quotient, or IQ, was introduced by William Stern. And he says that it is IQ equals your mental age over your chronological age being how old you are in years, right, times 100. And the IQ is actually no longer computed that way. That is not the way that it's computed today. David Wechsler, this is a big name, he developed the Wechsler Adult Intelligence Scale, WAIS, and later the Wechsler Intelligence Scale for Children, the WISC, being an intelligence test for preschoolers. And they are the most widely used IQ tests today. Okay, so yes, we have the Stanford-Binet, which is still a form of it still being used, but the Wechsler tests being the one that are most widely used. The WAIS measures overall intelligence. It consists of 2 parts. There's verbal and performance. Verbal being vocab definitions and comprehension of vocabulary and words. And then the performance is the timed assembly of small objects and arranged pictures in logical order. So you're given like an assortment of pictures and they say put these in logical order. Normally verbal and performance are within very close range, meaning the scores someone gets on those Yet separate scores can give a more precise picture of a person's specific abilities, whether they be in verbal or in the logical performance piece. These are some examples. So for instance, with the object assembly over here, they're asked to essentially put this puzzle together. That's what it is, right? They're asked to put that together, whereas the other one's being about kind of that, the verbal piece. Let's talk about aptitude and achievement tests. Achievement tests are intended to reflect, right? Reflect on what you have already learned, meaning they're assessing your current level of knowledge. An example would be the AP Psychology exam in May. Okay, that is assessing or reflecting on all of your knowledge you've learned this year. An aptitude test, they are intended to predict, not reflect, but predict your ability to learn a new skill, how well you could do. Examples would be the ACT and the SAT. Those are supposed to predict how well you're going to do in college, hence why colleges look at those so highly. Okay, let's talk about this guy named Flynn. So while Thurstone, Gardner, Sternberg, and Goldman, all these guys, all tried to define intelligence, Flynn is known for his observation that intelligence, as measured by IQ tests, is actually increasing over time. And we're going to talk some more about Flynn here in a little bit, but let's get back to the principles of a test. For a psychological test to be acceptable, meaning an intelligence test, it must fulfill three criteria: standardization, reliability, and validity. And we're going to talk about each of these separately. Standardization is when test items are piloted, meaning specific questions. Let's say 1 through 50 are piloted in one group and 51 through 100 are piloted in another group. And think about what piloted means. It's like a test run, right? Like the first episode of a brand new show is the pilot. And the network says, okay, the show did really well, we're going to approve it and go ahead and move forward with the next episodes. So test items or questions are piloted on a similar population of people, and norms have been established. We're going to talk about what the heck that means. So norms are developed, meaning the normal score from the piloted group, let's say, is a 75%, right? The most or the average or the median, whatever it is the norm. They're developed by calculating the average score achieved by a particular group, and then each person's score can be compared to see how it differs from people who have taken the test in the past. An example, an AP test is given to college freshmen as a final exam to set norms, or the OGT or end of course exams are given to a previous class to set those norms, known as the standardization sample. So the AP test that you guys take in May was actually piloted on a standardization sample, whether that was some freshman college students, or it could have been the previous years or previous 2 or 3 years AP psychology exam test takers. So they then take all of those scores and they find the normal curve essentially. And they say, okay, wherever the middle is, meaning the highest point, the mean, median, mode, we're going to shift these scores at the bottom, making a 3 a 3. So we're going to say that all these students who scored in the middle, let's say 75%, we're going to shift the 1, 2, 3, 4, 5 scale and make that, we'd call that 3. So periodically, tests are re-standardized, meaning what I just described to you, given to a random representative sample to reset and check the established norms, including intelligence tests whose normal score is 100. So let's look at this on the normal curve. Standardized tests establish a normal distribution of scores, that's the normal curve there, on a tested population. A bell-shaped pattern called the normal curve results. So what I'm getting in here, let's talk about it with the intelligence test. The normal score is 100, right? You're considered average if your intelligence, your IQ, is 100. Now, that is the same in 1848 as it is in 2016. 100 is the norm. The reason why it's staying at 100 is because they re-standardize the intelligence tests frequently, every few years, let's say. So what they find in their standardization sample is this normal curve. And let's say that this mean, median, and mode line here, the most frequent score, let's say it's like 80%, meaning most people are showing that they know 80% of what's on the test. What they're going to do is, and let's say that 50 years ago they showed that they knew 60% of the test. That means that today we're more intelligent, right? Well, then why is the average intelligence score still 100? Because what they do with these bottom scores here is they shift them. Okay? They shift them so that the 100 always stays in the center. We're going to talk about this some more in class so that we really conceptually understand. And that what I described in them re-standardizing and shifting is due to, you could say with the intelligence, as the Flynn effect. In the past 60 years, intelligence scores have steadily risen by an average of 27 points, a phenomenon known as the Flynn effect, and that there's been rising average intelligence test performance. And yet the average score is still 100 due to re-standardization. We'll talk about that some more. But why do you think we are more intelligent? Is because our genes have mutated and we are a more intelligent species today than we were 60 years ago? No. It's all environmental factors. Healthcare is more, well, you could say different things about healthcare, but healthcare is way more advanced than it was 60 years ago, right? We're all getting vaccinated and therefore not getting sick at times and therefore can focus on our brain and mental development. Schools are probably more advanced and more involved and better, you could say, right? All of these things, nutrition is better. We were all taking multivitamins. It's all environmental. All right, a test has to be standardized, but then it also has to be reliable. A test is reliable when it yields consistent results. So this means that on one day, the test yields an average of a 60%, but then the next day it yields an average of a 94%. Whoa, that's not really reliable. Why is it so different? It needs to be within a few points. So ways to test reliability are these three ways. A split half, dividing the test into two equal halves and assessing how consistent the scores are, meaning you give one half to one side of the room, one half to the other. Reliability using different tests, so using different forms of the test to measure consistency between them, and that they're like you shuffle the order of the questions. Retest reliability using the same test on two occasions to measure consistency. Give the test today, give the test in a week, the same exact test. Validity is the last thing all tests must be. So reliability of a test does not ensure validity. Just because something might be reliable doesn't make it valid. Validity of a test refers to what the test is supposed to measure or predict. Let me ask you something. How much do you weigh? In order to go find out, what are you going to do? Are you going to go measure yourself with a ruler, with a measuring tape? No. That would not be a valid measurement of your weight because the tape measure is not measuring what you are wanting to assess. Okay, so hop on the scale. Is the scale measuring your weight? Yes, therefore it's a valid test. But there's two types of validity. Content referring to the extent a test measures a particular behavior or trait. So is the AP Psychology exam measuring your psychology knowledge? Or do they throw some too many math problems in there and call it statistics, and therefore it's not really measuring your psychology knowledge? Predictive validity refers to the function of a test to predict a particular behavior or trait. If it's actually predicting it, if it's accurate, it's valid. Reliability of a test does not ensure validity. In other words, a test can be consistent without testing what it's supposed to test. So is intelligence fixed or does it change? And it kind of depends here. So there's two types of intelligence we'll talk about. Fluid reflects information processing capabilities, reasoning, and memory. Fluid intelligence tends to decline as we age because this is your ability to process new information. So think of like a 25-year-old going into an airport for the first, a new airport that they've never been to. They're probably going to make it to their flight on time, make the exchange on their layover in time and get home just fine. Put a 75-year-old in a brand new airport, it's going to be hard for them, even if they've been in an airport before, because they're having to process new information right? And make some assumptions about things, and that's hard. That's hard as we age. Crystallized intelligence. This is accumulated knowledge, skills, and strategies that have been learned through experience, and this tends to increase throughout life. This is wisdom, right? Think of like hard knowledge. Crystallized, meaning it hardens. It's like hard facts and strategies that you've used your whole life. So a 70-year-old may have more crystallized intelligence than a 30-year-old, but his processing will definitely be slower, which could make it look like he has less intelligence.